In our previous video, we talked about the definition of derivative and then its interpretations. So one interpretation of the derivative is it's the slope of the tangent line. The second is that it's also the instantaneous rate of change. And the third is, of course, that it represents velocity. Let's work on this in example 4. In example 4, it wants us to find the derivative of f at x, where f of x equals 4x minus x squared. So, of course, our formula is the limit as h approaches 0 of f of x plus h minus f of x over h. Let's first figure out what this part is, right? So that means that we're going to substitute x plus h in for x in this function. Let's do that over here. F of x plus h would be the 4 times x plus h, or minus the x plus h squared. So now we just accomplished this algebra. We'll distribute the 4 and get 4x plus 4h. Then reminding you back here, when we square x plus h, when we do that up here, that means we're squaring the binomial. So we distribute the x twice and get x squared plus xh. Then we distribute the h and get xh plus h squared. This winds up giving us the combined trinomial x squared, oops, we're subtracting, plus 2xh plus h squared. Cleaning that up, distributing my negative, get 4x plus 4h minus x squared minus 2xh minus h squared. Now none of these cancel, so this that we just found is the same as this first part of our numerator. Substituting that in, then we'll have 4x plus 4h minus x squared minus 2xh minus h squared. That is all the same as this. Then we subtract f of x, which is merely what we have above here. Cleaning over h. Now, if we've done this correctly, this whole second part of our numerator should cancel. So see here that I have a 4h, but then I'm 4x, but then I'm subtracting the 4x here. So those two will cancel. Now I have a negative x squared here. And this, I'm subtracting a negative x squared. So that really means adding. And so that one cancels with this one. What's remaining in our numerator is that 4h minus 2xh minus h squared and h. Now we'll notice that there is an h in each of these terms that can factor. So we do that. H. Now the h's that are being multiplied in the numerator cancel. This leaves us with, we do want to take the limit here. So what we have here is the limit as h approaches 0 of this 4x, 4 minus 2x. Minus h. Well, if h is approaching 0, this term will approach 0. So what this equals is 4 minus 2x, which would be our derivative of this function. Let's try the next one. In example 5, it wants us to use the fact that we found the derivative of 4x plus x squared to be 4 minus 2x. So we want to use that to find the slope of the tangent line of this function at 0, 2, and 3. And we learned our summary of interpretations of the derivative above told us that the derivative was the slope. So this function will give us the slope at these points. So if we want to find the slope, we're going to say f prime of 0 would be 4 minus 2 times 0. So the slope is 4. When x equals 0. Then we'll do the same with 2 and 3. So f prime of 2 would be 4 minus 2 times 2, which will give us, oops, that's just 2 times 2. Substituting 2 into this function, which will be 0. So the slope is 0 when x equals 2. For 3, we have 4 minus 2 times 3, which is 4 minus 6, or negative 2. So that means negative 2 is the slope when x equals 3. Now in part B, it wants us to draw that graph and the tangent lines and compare the slopes to what we got for our answers in part A. So I'm going to pause the video and graph it, and you can check that out. The instructions here told us to graph x minus x squared, which I've attempted to graph as this problem here you can see. Then it says draw the tangent lines and compare the slopes of the tangent lines to what we obtained in part A. So if we scroll here a little bit to remind what we obtained in part A, was we found that the derivative at 0 was the slope to be 4 when x is 0. So here's x is 0, and the slope of that tangent line drawn to the best of my ability is about 4. There. Then f prime of 2 would be the function value at 2 and its slope, and we have a horizontal line, so that indeed has a slope of 0. And then at 3, we found the derivative to be negative 2, which, well, pretty close, would be the slope at the tangent line at the point 3. All right, in our next video, we will try a few more applications of derivatives. Thanks for watching.